This chapter is entitled Performance Tuning. Probably would be, I think, better title maybe Performance Monitoring, because that's really what it's about. The tuning, what's using the resources. To find that out, we've got to have the performance monitors to do that. And there's going to be a couple of things that we'll look at. They have improved, we're going to look at Task Manager. They've improved Task Manager with the Resource Monitor tab. If you haven't looked at that, it is tremendous. It shows you by service, by application, what's taking the resources. I know there are services tab. It's a much more extensive tab when we go there. Several key performance enhancements in Windows 7 over, and what we're really talking about here when we talk about enhancements and all these changes, we're mostly talking about enhancements over XP, because Vista, and you guys have looked at that, I think at least some in the computer configuration and management class. Vista is very similar to, much less efficient than, much less stable than, but essentially the same operating system. So what works there, and oh, by the way, if you take the A+, they're probably not going to ask you Vista questions anymore. They're going to ask you Windows 7 questions. Configurations work the same way. Describe performance tuning concept. Performance tuning, what are we going to do? And again, what's taking the resource? Do we turn it off? We looked at one of these chapters back earlier. You looked at the fact that you can change the priority of applications. So if you've got something that needs to run in the background, you can set the priority lower. The thing that's going to have the highest priority is always going to be whatever is in the foreground, whatever we have active, the active window, whatever you're working on. Use Performance Monitor. We'll take a look at it. Use Task Manager. You've done the Task Manager. You know how to configure tasks and those sorts of things. Understand performance ranking. And the performance ranking is the performance ranking of the machine. And you won't be able to do that in the virtual machines because they don't calculate one, because they're really not connected to directly enough, at least, the hardware in order to do that. Optimize system performance, those things. The enhancements, Windows Superfetch is something that is kind of neat, and they don't have a slide on it, but if you'll read about it, it's the thing that takes all the memory. If you will look at the memory utilization in Windows 7, you'll probably find it's much higher than it was in previous versions of Windows. Superfetch is a service that allows the operating system to monitor what you use most and keep that loaded into memory instead of having to page it in and out based on the age of the application. So it's one of those that you see, say, do I really want to run this one? Yes, you really do want to run that one. That's what that one does. Low priority I/O says that everything can have a little bit of time, so that and this would allow background applications to run and finish what they're going on. Windows has a priority scheme where on clock cycles it actually changes the priorities of everything it's running so that everything gets a little bit of priority at some point in time when we do those things. Windows Ready Boost, anybody use that other than me? I use it on my machine in the office because it's such a real powerful machine back there.
Yeah. Oh, where you plug the flash drive?
Plug the flash drive in and allow it to map the flash drive as a pseudo memory, yeah. Ready Boost. Does it help? I think it does a little bit. If you've got a machine with sufficient memory, you really don't need that. My machine doesn't have sufficient memory, so I really do need that. Windows Ready Drive. This is something that allows you to use the flash capability of the newer hard drives. Newer hard drives do caching and flash, and that's what that one is all about. Automatic defragmentation. Automatic defragmentation, if you look in the task scheduler or scheduled tasks, you'll find that when you install Windows, it's scheduled a defrag, and I think it's like Wednesdays at 2 o'clock or something like that, but there is an automatic defrag schedule weekly by default in the system. All of those things are helpful to maintaining the operating system at the maximum performance. You could always go back and schedule any of these things you want, defrag, check disk, those kinds of things. Check disk a little bit more difficult because it has to unmount the drive in order to actually do that. But you can schedule those things yourself if you want them to run on a regular basis. Like your antivirus probably does a disk check once a week or something like that, doesn't it? You have it set up to do that? Yeah. It's a scheduled task. So you can do those things should you want to. Performance tuning a process rather than event. I guess one of the things about performance tuning is you need these monitors to know what's normal, because if you don't know what's normal, you don't have any idea what abnormal is. One of the ways I think to think about that is gas mileage in your car. You buy a car and the EPA tells you what it's supposed to get. Of course, that if you look at that, nobody ever actually drives a car. They just estimate it based on what the manufacturer is telling. So you buy this car and it gets, let's get a good one. Let's say we get 50 miles a gallon. Everybody would like that, right? And you're monitoring it, and all of a sudden you go to, you say, I think I'm buying more gasoline. How do you know if you're buying more gasoline? What will show it? What will show it? Maybe, maybe not. Maybe you're driving more miles. Your credit card's probably not going to show it. That's where you're going, right? Your credit card may or may not show it. What if you're driving more miles now? Are you driving more miles? You're doing the same thing? If you monitor your gas mileage, you're going to know when that drops. And is there an issue with that? Computers are the same way. You need to establish a baseline, and servers are general. I know this is a client class, same thing. Servers are generally what we're more concerned about, but you need to establish a baseline. What's the processor utilization? What's the memory utilization? Disk, and those sorts of things. What's normal, so that as we monitor these things, you can determine what abnormal is. Consists of, here's my baseline, recognizing bottlenecks. What's a bottleneck? The top of a bottle. But we don't have any bottles stuck in these computers, do we?
Yeah, it's a choke point.
You stick some in, it's a choke point.
For linear ambush.
For linear ambush, but for anything, it is a choke point. So what would be some bottlenecks in computers, do you think? Too much processing on one service or one application? What about your dial-up modem on the internet? What about your 5,400 RPM drive? Wow. That's fast. They're still out there. So choke point is basically wherever the slowest component is when we do those things. And then tuning performance, try to make that better. Try to make the choke points, the bottlenecks, as inconsequential as possible when we do that. Establish the baseline, so what's normal, so we know what abnormal is. The baseline's a set of performance data, and that's something that you establish. What do you want for your baseline? So that we know what's there. The performance indicators are called counters, and when we look at these things, they're going to be called counters. So what you're going to add it in the performance monitor, we'll look at that. That's just going to be the name of it. And the counters are basically, we're going to add the NIC, we're going to add the hard drive. What components are we going to do? No unusual activity in the baseline. The baseline really needs to be established over some time. You can't go in and measure everything at 8:30 in the morning and say, hey, here's my baseline. Is 8:30 in the morning the same as at 8 o'clock in the morning? Because you get things like 8 o'clock. What happens early in the morning at 8 o'clock? And even here, what happens about 8 o'clock? Everybody comes in and logs in. So some activities are going to be much higher. That's going to be the baseline. That's going to be the norm then. But would you expect that same activity, let's say at midnight? What kind of network activity? Would you expect a lot of activity at 2 o'clock in the morning? What's that? And if you see that, you're going to say, what's going on? Does anybody look at that monitor that Chris has got going up front? Do you notice that little one? He's got that big peak in network activity at about midnight to 2 or something like midnight to 4. What the heck's going on there?
Backups.
Don't think so. Maybe.
Either backup.
Maybe. So I don't know which switch he's actually monitoring. It could be something on the iSCSI drive. Could be backups.
Now, is that for here?
It's for here in this building. It's for here, not in this room. It's for here on what's called the student switch out there. I don't know what all he's got on it, but now you've got an indicator that says, maybe I need to check this out. What's going on here? What changed? What could it be? It actually could be iSCSI because we put some more iSCSI connections in. Bottlenecks, current limitation of a single computer or component, the disk bottlenecks, faster disk, and all this stuff. The one that I love is when you get into the computer itself, do this upgrade, do that upgrade. The answer there may be buy a new server, buy a new motherboard for these things. How much can you actually upgrade these things? And when you look at upgrading, one of the comparisons you need to do is what's it going to cost to upgrade versus what's it going to take to buy a new system and what's going to be the life expectancy of each. Is it worthwhile? It's kind of like a car. You're going to trade in your car? How much is it going to cost you to trade it in? How much longer do you expect yours to last? And my favorite, when I was a youngster, I was always a cheapskate. I wanted to trade in my car for one that got better gas mileage. My dad said, how long is it going to take you to amortize the cost of that car by buying gas? And this was when gasoline was 30 cents a gallon. So what's it going to take to amortize the cost? Which one is going to give you the most bang for your buck? And that's what businesses are looking for. That's not what we're looking for at home, but when you start doing these things, don't think about your home computer. You've got to think about a larger scale. This is not a big organization here, but to upgrade these computers, to put new machines in, you got to buy, I don't know, about 300 of them. In a lot of businesses, that's not very many, but that's pretty significant investment. Is it better to do that? Is it better to upgrade them? Are there other methods to take care of these things? And sometimes a bottleneck's not a bottleneck. It's just that it's inconvenient for people. But what are these? Disk performance, the upgraded drive controllers, upgraded disks. Upgrade the disks or implement a RAID. If you implement a RAID 0, that will increase your disk speed. The hazard of a RAID 0 is there's no redundancy. If anything happens to any disk in that RAID 0, you just lost all your data. So you better have backup if you use those. Same thing with disk spanning. If you do those without redundancy, please be sure you've got backups of that data, because if anything happens to any of those disks, everything's gone. They won't rebuild. A RAID 1 and a RAID 5 you can rebuild. RAID 1, obviously, you have a copy of everything. RAID 5, if you lose one disk, you can rebuild the RAID. You can rebuild the data from the RAID, from the parity stripe. Move the paging file to a non-system disk. I've already told you about what happened to us on our paging file, and also be careful about how big the paging file is, how much memory have you got in the machine, because the paging file is going to wind up being basically the same size as the RAM.
What exactly is a paging?
A paging file is an area on disk.
Okay.
We'll send you back to DOS. An area on disk that's mapped like memory.
Okay.
So when you run out of memory, and you always will in Windows, if you've ever noticed that, right?
Yeah.
Regardless of how much memory Windows has, in our server it had 98 gig of memory. And how big of a page file did it have? 98 gig. Did it really need that? No, but it made it. What a page file is it maps that area as memory so it can swap stuff in and out based on what actually is, because the applications that you're actually using, the active stuff, is what goes in physical RAM.
Is it sort of like a backup RAM?
It's sort of like think of it as a holding area.
Okay.
And as you need those things, the paging part is it's paged in. It goes a page at a time, goes into memory. And the oldest thing in memory, a page at a time, is paged onto the paging file. It's kind of like storage, but it's supposed to be, is a little bit faster than RAM because it's than disk, because disk has got to go find the stuff and load it into memory. It get loaded into physical RAM, and if you then load something else into physical RAM, it'll get stuffed away in here. It's kind of like, it's in a ready reserve area, so that when you need it, it's just put right back into RAM. But back to the first slide, Superfetch is supposed to analyze what you use the most and keep those things in physical RAM, and they're not paged off, which should make the Windows 7, Windows 8 machines faster by doing that. Does that make sense? Yeah. Memory bottlenecks. And what's your best indication of a memory bottleneck? Same as any other bottleneck. What's your best indication of a memory bottleneck? Slow performance, lagging, the hard drive's beating itself to death. And why is the hard drive beating itself to death? Because all that stuff being paged in and out of memory, paged in and out of RAM. The best first indicator, other than you might have a virus, of insufficient memory is that the hard drive seems to run constantly. Hard drive light's always on, assuming that you hooked up the LED. Processor bottleneck, too much work for the processor. To resolve these, change to a faster processor, add additional processors. Yeah, that's real easy, right? What does that mean? You've got to add additional processors, or change to a faster processor means that your motherboard's got to support that. That's why I say a lot of these things are, when we get into some of these things, add this, add that, add processors. You're going to take your soldering gun and go put a processor slot on the motherboard, right? So, I know I'm being facetious, but some of these, what are you really going to do? Change to a multi-core processor. To do all of that, you're probably going to have to change the motherboard, aren't you? And you're probably going to get faster RAM that way, different disk controllers maybe, those sorts of things. A lot of stuff. So it goes back to what I was saying earlier in this one, they upgrade. Well, maybe. You may want to, instead of upgrade, look at how much upgrading you're going to have to do. And maybe it's more efficient to buy a new device, a new server, and take the information from one to the other. How much upgrading can you do? You can do quite a bit, but at what point do you meet the point of diminishing returns on those? And there is one out there. I mean, it's just like the car.
Well,
At what point do you meet the diminishing returns?
I mean, you can have any type of case and make it either run like an E machine or.
Well, kind of not any type of case. You got there's some specifics you got to get in there. You got to buy what fits.
If you got like a good mid-tower AGX.
Mid-tower, but mostly servers are going to the much thinner profiles, the low-profile devices. So, do we want to run it in there? And a lot of that's for cooling because the processors are really going to be pretty hot in here. We've run some towers. Both of them run about the same, but how much horsepower do you get in any of these things? You really need to look at that. Network bottlenecks. Are you going to run into those? Yeah, maybe. If you do something like iSCSI, and I keep saying iSCSI, what do I mean when I say iSCSI? What is that? That's when we connect disk space over the network. Internet SCSI, Small Computer System Interface. It's a system so that we can create virtual hard drives on a server with a lot of storage, multiple terabytes, and then connect it via a network connection to other devices. We're running a couple of iSCSIs on our virtual PC server. So the information is being transferred across the internet. Could we get a bottleneck there? Absolutely. What are the ways around that? Multiple computer accessing a single server may overwhelm the network connection. And when we get in, actually not when we get into it, I'll mention it here. There's a thing called channel bonding, NIC bonding, ether channels, what Cisco calls it. What you do is take, using the systems, the devices that support it, and if we have two NICs, 2 gigabit NICs, we bond them, channel them together so that they appear as one NIC, one IP address, and you have a 2 gigabit connection instead of a 1 gigabit connection. So that's something. Does it support? Can you do that? The other methodology is to have multiple NICs on the same network address. You can do that also, and then you would use DNS, which we really will talk about in the infrastructure class. What's called round robin. It goes to the first one, then it goes to the next one, and it goes to the next one, depending on how many you have. So it does a round robin on which resource it sends you the IP address for to access. Steps: create the baseline, compare the baseline, identify the possible causes for variations. Same thing. If your gas mileage goes from 50 to 30, are you going to be curious? Are you going to try to figure out what's going on? Because something's happening with the engine, right? If you're processing, and what we love to do is, my internet connection's slow, and the internet was slow yesterday, according to everybody, because there was a denial of service attack going on.
Was it really?
Yes, there was really. And what were they attacking? DNS.
Yeah.
Because they found out it's a lot more efficient to try to attack DNS than it is trying to attack servers, because you can do less filtering on it. So, yeah, there was. At least that's what I saw on one of the blogs that I read, one of the security blogs, that there was a denial of service attack against a company that publishes a list of spammers, so that people cannot let them use their email servers. All of those things. So this is basically, I think, what we've talked about before. What's the baseline? What's normal? It's abnormal. Now we need to go into all of these monitoring devices and see what is abnormal. When your computer locks up, probably go into Task Manager, look, see what's got the 100% processor utilization, and kill that process. And then everything is good, right? In a server, you can do that, but you need to go, I think, one step beyond what caused it. Because a server affects a whole lot more people and a whole lot more of the company than does a single machine. Performance monitors and MMC snap in, the areas: resource monitor, performance monitor, reliability monitor, data collector sets, and reports. I think what I would like to do here again is to open one of these things up and go through what these things are. If you'll remember those, and I think it will show it to us, and they've got some nice pictures here in Resource Monitor. Why I'm going through this is I want to look at one. Network, all of those things, and we keep coming back to the same picture because that's the starting point. And the Performance Monitor. The counters term we had earlier, we'll look at the counters here in just a minute. The chart types, line, histogram, or report. Depends on how you want to look at it. The report is an instant in time if you take a report. The others are actually changing with time, and you can determine how much that time is. And then data collector sets, we'll take a quick look at those. Data collector sets allow you to collect data over time and store it to a file. That's all that really is. A couple of different ways to store it. When do you want to do these things in the data collector sets? We'll look at that. Alerts for performance counters. For performance counters, you can configure it to send an alert to you if you go beyond some predefined limit. When you do these things, you need to see what's going on, because if you go in there and say, hey, I want to know when the processor utilization is 100%, you're going to get monitors all over the place, because processor utilization jumps up and down, go to 100% and go down as a process starts, and then it may go down to 0%. You probably want to set, maybe if processor utilization goes to 100% for 2 minutes, then let me know what's going on. Because you're not going to sit there and watch these things 24 hours a day, 7 days a week. I want to get to the end of this before we go into the other one. We're still in data collector sets, reports, our log files, rules in XML file, the reports, and they'll have you do that, and then we're in Task Manager. Actually, we're going to look at Task Manager because that's how we're going to get there. The applications, what's in it, the processes. See how I get through these really quickly? You got all that, right? Performance tab, other tabs. Performance ranking is the one that you're not going to be able to do on the virtual machine. The Windows Experience Index, what it is, whatever is the lowest number is the one that's going to give you the index for. You probably, well, actually I'll do it on this one up here so you can see what one is. These are the things that it ranks. I tell you, generally what's going on. Generally what's going to be the lowest, or at least on our machines, is going to be video. Regardless of what else it's got in it. These machines are all going to be video. I think we'll look at that one. This one's 4.2. It says processor 4.2, memory 4.5, graphics 5.9, gaming 4.9, primary hard disk 5.4. So, determined by the lowest subscore, 4.2 is going to be the computer score. Is that significant? Maybe.
Is it kind of telling you
Maybe.
what the bottleneck is for the computer?
Maybe. You live these maybe answers, right? Depends on what you're doing with the system. If I'm on the internet, how much processing actually goes on when you're surfing the internet? And this one that says the processor's the low one. Is it? And that's why I say maybe. Depends on what you're doing with the system. Generally speaking, yes.
Basically, that's your weakest link.
Yeah, your weakest link. And if it comes up with graphics, do I really care? Unless I'm a gamer. For real. Unless I really want all this really cool arrow stuff, then graphics might be significant to me also. Individual subscores, rankings from 1 to 5, 5 to best. Not a simple average of the subscores. It really just takes the lowest one. Base scores, base score 1 or 2, and all those things. Depends on what you want, what you buy. How good is it? What's important to you when you go through those things? If the processor's the lowest and you have a really good processor, so what? I'm going to get back to the other stuff here. Performance options, we've been here, done that, right? Adjust for best performance, adjust for, let Windows do it. Windows turns everything on to make it look pretty. You want it to look pretty? Leave it there. If you want your virtual machine to work more efficiently, adjust for best performance. If you want your not real strong machine at home to work more efficiently, adjust for best performance, because the default is let Windows figure it out for you. Not always the best choice. Depends again what you want to do. You can let Windows choose the best for my computer, which is going to most cases turn just about everything on. Adjust for best appearance or adjust for best performance is what you have there. What are you doing with the machine? Virtual memory, here we go, Josh. It's managed automatically by Windows, and automatically by Windows is probably going to create a page file on the C drive that's about the same size as memory. They usually say 1 to 1.5 times physical RAM. That's how big a page file should be. It is a reserved amount of disk space that is mapped as memory. If you have separate physical drives, the page file ought to be on a drive other than the operating system, because you're always going to be loading stuff out of the operating system, and the page file, if it's competing with the operating system, may slow the machine down. So if you've got 2 physical drives, they need to be on different ones. If you've got 2 different partitions, yeah, that really makes you feel good, but you really haven't physically changed anything. Same read-write head, the same controller, the same communication channel.
So
different physical drives is the preferred way to do this.
So the terms are interchangeable, virtual memory and page file?
Yes.
Okay. Okay.
Yes. Minimum size is 16 meg, maximum size is 300% of RAM. Whatever you think you need on them. I actually, on my little weak machine in the back, and it still runs turned off, just so I don't have one, I turned off the page file. And it still runs. Actually, it seems to run a little better without it. I think because I have a really slow disk. Can manually configure these things, and most Windows 7 computers have one. And increasing the performance is not possible by adjusting this or changing where it goes, actually changing where it is physically located, and we'll take a look at that on the physical machine over here. Can specify that no paging file be used, and this is all part of the computer configuration one. What you can't see here, because it's highlighted, it says C, and it says the paging file, and it says system managed. You can do a custom size. If you do a custom size, the typical recommendation is that the initial size and the maximum size be the same size so that you don't have to wait for it. You ever get one that says that you don't have enough virtual memory?
Yep.
And it just goes away. That's when Windows is changing the size of the page file. And if you do the min and the max, you can get it defragmented. You don't have to have the fragmentation issue, because remember, since this is a file, if you create some of it at one point and some of it later, it's not necessarily going to be contiguous and going to be as efficient. If you configure it to min and the max the same, you have a lot better opportunity to get it to be all in one, in sequential sectors on the disk. That will make it more efficient. Data execution prevention can use monitors the processes to ensure they don't access unauthorized memory spaces, and this is on by default. I think, I think that the server's one and the Windows 7 is the other, and when it turns it on for the Windows processes. You can turn this on for everything or just for Windows. It's something that probably should be on, because this helps in the virus area, so that something is not able to get into the operating system memory areas when we do those things. And this is just what it looks like. Turn on depth for essential Windows programs and services. Turn on depth for everything. Two choices, and you can pick whichever one you want. And then we have the summary here. What else? Let's look at that, and then we'll go back to look at the other things. Higher performing operating system. Baselines are important. Baselines are important for your own individual machine so that you know what's abnormal. Probably more significant in the server world, because it's going to affect the performance. The server is going to affect the performance of the company more so than individual machines. Data collector sets, and again, we're going to look at those things. Task manager, performance rankings. As Sharon says, yeah, it's probably going to give you the choke point, the weakest link in the whole system. Is the weakest link going to mean that the system's no good, or depends on what you're using it for? If I'm just doing word processing and internet, I don't really need a whole lot.
Is there a possibility that performance ranking can change?
Can performance ranking change? Absolutely, as you change components.
But only as you change components?
Well, as you change components. Yeah, because it has its own, and you have to tell it to go back and recheck it. So, yeah, it can do that. So, let us quickly, I was going to start it on this machine, try to start the stuff on this machine. First, let's look at Task Manager. Start Task Manager gives us the applications that are running, the processes that are going on, and in this one that we can go into, we can refresh, select the columns. All the columns don't show up. If you want to see more or see less in this, you can select what you do want to see. So we got CPU, CPU time, we'll add CPU time. CPU time just tells us how much time that process has used the CPU. And you notice here, not a whole lot is going on with any of these things. And the amount of memory that's being used, you click on any of these things up and down. PowerPoint here is using the most of us. The camera recorder to record this thing is 46 meg. And we've been going now for what? I've been going for 35 minutes or something like that, recording. The processor time, here it is 10 minutes and 52 seconds. So just because something's running doesn't mean it actually has processor time that whole time. The services that are running, and you can, a big list of services here, and we get the services, the list of services, you get the running and the stop services. You can stop, you can go to the process that is taking that service. So if we go to the process here, we go back to the processes, takes us back and forth. Services. Performance just gives you an overview of what's going on at this instant in time and a very short period of time before that. And this is a dual core processor, so I get what's going on each of the cores, how much processor time is being taken. And down here we have memory. Networking is something that's been added. This one shows a whole bunch of them. Local area connection, Bluetooth, wireless network connection too. You're going to have to see what you're actually using on any of these things. And mine looks like I got up to 0.01% there. Local area connection is the one that actually is doing something. You can see what kind of bottlenecks you're getting, if you're getting any network bottlenecks. And if you've got a local area network, you're probably never going to get there on your internet connection because the odds are it's not as fast, never going to be, at least until you go buy something really big, as fast as your local area network connection. Because we're talking, what, megabytes on the internet, even a really fast connection, what, 40, 50 meg if you buy the real high-speed cable versus 100 meg or a gigabit. So those may or may not. And then the users that are logged on, and you can disconnect or log off users here. When we talk about disconnect or log off, if you disconnect somebody, whatever they had running continues to run. If you log them off, it shuts down everything that they had running. So you can disconnect the user, and if they had their term paper open, it would stay open, and they could log back on and pick up where they were at that point. And that's one of the disconnect versus the other one. The other thing we needed to look at was what? Performance monitor. You can go through a lot of different things, or you can just go to the combined run search line and type perfmon. The performance monitor, and in here, as soon as it starts, we have those things that we talked about. Performance, you can, if you have the authority, connect to another computer, which means that you don't have to go out and spend several $100s for a third-party utility to monitor your servers. As long as you're the administrator, you can connect to your servers right there through this thing. What those generally do, those third parties generally do, is give you a nice interface to run the things that are already available to you. Integral to it, yeah, to a lot of things. Integral to itself anyway. But yeah, it's there. Windows usually plays pretty nice with Windows. Windows usually doesn't play pretty nice with anything else.
The only problem is
Yeah, there are some backward compatibilities. The performance monitor here, the default, when we look in here, we can add counters, and the counters are the things that we're going to monitor, for lack of a better word. And I think that what we have in here, if you look down here, percent processor time, that's the default. Always going to be the default. If we want to add something in the counters, if we want to look at physical disk, for instance, percent read time, we go on and on and on. And what's there, just about anything now that you really would want to monitor. take a look at those things. Browser, what goes on, database. We don't have a database on this one, but if we could go down to network interface. If we look at the network interface, the things we want to watch about, bytes received per second, bytes sent per second. And when I went into that thing, it said, I'll do all of them. And when I then look at that, you saw all those NICs that I have. We can specify all instances, which is all the NICs, or if we're only interested in a single NIC. For instance, this one has a wireless NIC. If I only wanted to watch the wireless connection, I could pick that. So we have the counters, and then in the counters, after we pick the counter, let's do packets per second. Go down here, and I've got to find my right one. Wi-Fi, ISTAPI. Let's do the Intel network connection, and then I can add it. It should then, although I don't have a lot of activity here, it's not going to show a whole lot. When I say OK, it shows up down here at the bottom. When you click on it, it tells you the last, the average, and the minimum of whatever goes on here. You can also configure this thing. If we go into the properties, you can change the general legend bar, the default, how often you want to sample it. This one says it's going to sample it every second. That may be too often. If I wanted to sample it every minute, I could sample it every 60 seconds. The duration, how long is it going to do this for you? The duration is actually how long it takes to go across the face of the display here. So 100 seconds, if I do it every 60 seconds, let's say that we want this to be every 500 seconds, I can apply it. It's not, we'll round up. So 540 seconds to make it work. 540 seconds would be 9 minutes, right? Is that right? Yeah. The sources, the current activity or log files, the data, what we're going to do. We have the network interface and the processor. We can add and remove things here. And when you go down here, the scale, and if you want all of this stuff to fit together, you're going to have to figure out, go through your scale. Some of it may be much smaller than others, 100%, and then the other one, bits or bytes or whatever else, maybe large or small where they will or won't fit. You can change the scale on these things. And then we get into graph. What do we want to show, a line or a histogram? The histogram, since I changed it, we're going to have to wait for we're going to have to wait a little bit. Well, let me go back to, shows you the properties though. Let's go back to doing this every 1 second. And then we'll do it every 100 seconds again. What this will then show us is a bar graph. Or the histogram is going to be a bar graph. The line is going to be a line. And all the lines, say this one did pop up here a little bit, that's where your scaling would come in. If I need this to show a larger scale, then I would go to that individual packets per second, change the properties in it. Instead of scale of point, let's see if we can make it much bigger, huh? I picked packets per second, processor time, scale of 1. So I made this one really big, but now I've killed my processor time because my processor really not doing anything. But it's still going to, the scale over here is going to be 0 to 100. This is going to be some percentage of that scale. If I wanted to create a collector set, and a collector set is just something that's going to collect this information and store it in a file on disk, I can create a collector set from a performance monitor by, as you see, you're right-clicking on the performance monitor, new data collector set, and it'll go create it for me. If I want to create individual collector sets, I can go down here and in the user-defined new data collector set, and I've got a couple here. This one's not running. If I wanted to do a new one, start. Actually, that's going to start these. It's going to start the collector set data so we can start and stop them. Save the template. Down here, new data collector set, and we'll call it Demo 2. What do you want to monitor? Here we're going to add our performance counters, get the same listing that you had before. I'm just going to go pick something here. Let's do processor just for the heck of it. And we can add all instances for this thing. Okay. What's the interval going to be every 15 seconds, just to get one in quickly. And then I made Demo 2, and I have properties. I can go back into the properties and what log format. Binary, you're probably going to have to go back into this thing to look at it. I have, just for my own self, I always use comma-separated values, a CSV, because then I can open it in Excel and do the analysis there. So you can specify the format that this thing has. And every 15 seconds, every 15 minutes, every 15 hours, whatever you want to do in those things. And now we can go in here, we can delete it, do the properties, hopefully start this thing, and we get a location. The location is /perf logs is an area that Windows makes that is available to store, is where the logs would be stored. You can do some other configurations with these things. The other one that kind of is useful when you go into this is the system diagnostics, which are already created for Windows. You can go in and look and see do some analysis on what's actually going on your machine. When you get done with these things, I think that this is the system performance. Here we don't have anything in here. System diagnostics, because we really haven't used anything. But in our user defined, we could go in and look at these things. The system overview, we don't have anything yet. System overview not running. You can turn those things on and see what Windows thought should be available to you. But they've got activities, exercises for you to do here. That's a quick and dirty on that. One of the things that I will, because I messed it up several times, pay attention to, if you leave those data collectors running, they'll keep running. And they'll keep collecting data for you. And they'll keep building the size of those files. And they'll keep taking disk space. And if you let them run for a couple of years, they can take up some pretty significant amount of disk space, like a couple of 3 gig. So look at that every once in a while too, what's going on. And you can set up a performance monitor to monitor your disk space, right? So that you can do all of that. Those are the areas that's what was there, right? So what I said I was going to go back and look at the different areas that are in there. They got all those slides. They have activities for you to do. This is an area that hopefully won't take a whole lot of time, and I don't have a whole lot of questions for you to answer in these labs, but I ask you to leave your performance, the ones that you create, leave them running. And go ahead, and I think it were okay. I'll check it again this morning, okay, on the disk space that you can leave these machines running, because we move some stuff around and hopefully create enough disk space. The hazard of not being here on Tuesday was that you may got to move to a slower disk. Hopefully they're working okay, but they'll work. They just may not be as fast. I did some modifications that on the disks themselves that makes them hopefully more efficient, but less safe. Everything is a trade-off in the Windows world. Are there questions about this one? Let's take a break and then come back and do the